Hello, my name is Scott Golightly, and today I want to talk to you about how you can use the Database Engine Tuning Advisor in SQL Server 2008 to help you to optimize your database. In order for us to use the Database Engine Tuning Advisor, we need to have a workload that it can work off of. So I have my SQL Server Management Studio open, and I'm going to create a workload file. My workload file will be just a few SQL select statements, or if I wanted to, I could run SQL Server Profiler and trace the activity on my database. The important thing to remember is that the workload file that we give the Database Tuning Advisor needs to be representative of the work that we're going to do. Because I'm only typing a few select statements here, it's not really going to be representative, but we can still see how the Database Engine Tuning Advisor works. So the first thing I need to do in my workload file, if I'm going to use a SQL file, is to tell it which database I want to use. So I'll start off with and say use AdventureWorks, and then I need to type in a couple of select statements so I have some work to do. So I will select out of production.product the product ID, the name, list price, a cell start date, a cell end date, order date, and finally order quantity. I'm going to select those from my production product table, and I will join that to the sales order detail table on the product ID. And then I'm going to also join in the sales order header table. And that will be on the sales order ID. And then I'm going to execute one more select statement. In this one I'm going to get a total of the dollar amount by customer, and I'm going to order it on dates. Actually, let me go back up to this other select statement. I want to add a where clause in here, and I'm going to look for products where the sale date or the order date was within a year of the sales start date. So I'll say where date diff in months of the product dot sell start date and the order date is less than 13. So within a year of the time of this going on sale, the product was actually ordered. And my next one is going to just be a select of sales sales order header, customer ID, and then a sum of the subtotal column, and that's going to be from sales order header, where the order date is less than, we'll say January 1st, 2002. So any orders in 2001. And I need a group by, and in this case sales order header, customer ID. So I have two queries. Both of them are using where clauses on dates, and I know that I don't have indexes on those right now. So if I execute these, just to make sure I don't have any syntax errors, I do have an error. I'm missing an on statement. That's the problem. Okay, now let's execute, and I get back both of my result sets. So I know that this is a good file. I need to save this. And we'll just call it workload.sql. Now I'll minimize my SQL Server Management Studio, and I'm going to open in my SQL Server Tools. I'm going to go into my Performance Tools and then run the Database Engine Tuning Advisor. It's going to ask me the server to connect to, and then it's going to start asking me for information about this tuning session. So the first thing is a session name, and in this case I'll leave the default, which is just the date and time. The workload, it's either a file, which could be a trace file or a SQL file containing statements, or it could be a table if I have done my tracing into a table using the SQL Server Profiler. I'm going to open up the workload file that I just created, and I'm going to tell it that I want to tune the AdventureWorks database. And actually with SQL Server 2008 I have the option to tune multiple databases if I have joins or statements that operate across multiple databases. I could also select which of the tables I wanted it to index. In this case I'm going to leave all of the tables selected, and then I'm going to look at my tuning options. I can limit the amount of time that I will spend tuning this. So if it's a large workload file and it's going to take a long time, I can limit it and say just examine however much you can get done in a certain amount of time and then give me the best results. I can look at the physical design structures, indexes, index views, non-clustered indexes, and I can also look at partitioning. I can tell it to not partition tables, align partitioning, or full partitioning. And especially with Enterprise Edition, there are some significant improvements that can occur because of partitioning. So since I'm running Enterprise Edition of SQL Server, I'm going to check the full partitioning here, and then the physical design structures to keep. So this is going to ask me if I want to keep any, keep indexes only, clustered indexes only, align partitioning. I'm going to say keep all the existing ones. I don't want to drop anything or remove any indexes. The main reason I'm doing this is I know that this is not a representative workload, that I'm not hitting all of the tables in my database, and if I told it not to keep any existing data structures, it might go through and recommend dropping a whole bunch of tables because they're not being used. Under advanced options, I have space for recommendations, how many columns per index I'm willing to recommend, and then if I have some index recommendation options. I don't want to change any of these, so I'll click on cancel, and then I can click on start analysis. This is going to read in that SQL file It's going to examine it for the queries. It will figure out what the optimal index schema is going to be. This is finished, and it's come back with some recommendations. The first thing I can see is that the recommendations have an estimated improvement of 56% on these tables for this particular workload. It's recommending that I create a couple of partitions and then 5 indexes down here on product, sales order detail, and sales order. At this point, I can optionally do a secondary analysis. I can go into my actions and say evaluate recommendations. When I click on this, it's going to take the selected recommendations and run another analysis on that as if those recommendations had been put in place. So I can do what if analysis on this without ever having to make the changes and see the performance difference. So I can then again start the analysis on this. Again, it's going to look at the workload file, look at it as though those indexes and partitions had been created, and tell me what it thinks the performance improvement is going to be. And I see that again the estimated improvement would be 56% with the same recommendations coming back. So at this point, I can go into actions and I can either apply the recommendations if I want the SQL Server to go out and create the partitions and create the indexes for me, or I can save the recommendations. By saving the recommendations, this allows me to do my analysis on a test server or on a single server if I've got replicated servers or multiple servers in a SQL Server farm, to just do the analysis once and then be able to take that recommendations file, the output, and apply it to the different servers in my server farm. A lot of people mistakenly think that SQL Server is self-tuning and will create the indexes on its own. While it does a good job of maintaining itself and really trying to help the DBA with performance issues, there are some things that you need to do, and making sure that you have optimal indexes is one. The other thing that you need to be aware of is that over time, as applications change and the way that data is distributed changes, your indexing schema may need to change as well. So this tool will allow you to examine your database and the workload that's occurring on it and define the optimal indexing schema for your particular operations. By making the Database Engine Tuning Advisor part of your regular maintenance schedule, whether that be once a month or once a quarter or twice a year or something like that, you can really improve the performance of your database and keep your users happy.